two blocks, A and B, are connected by a rope and are pulled across a frictionless table by another rope that carries a tension T1. What is the ratio of T2 over T1? Where T2 is the tension carried by rope 2. In this situation, we want to draw a free body diagram for each of these blocks, and we'll see how the forces acting on each relate to each other. So if we look at block B, we know that we'll have a force of gravity downwards, and we'll have a normal force upwards. And from experience, we know that this normal force and the gravitational force will be equal and opposite and will balance each other out. If we look at B, we should have gravity acting downwards and the normal force acting upwards. The only other force is T2, where T2 is the tension that is carried in rope 2 and is acting towards the middle of the rope. Acting towards the middle of the rope means away from the endpoints, to the right from this side, to the left from that side, and that tells us that the tension is acting to the right on block B, it's acting to the left on block A. So when we're looking at the forces acting on B, we also have a value of that tension, T2. Doing the same for A, we have a force of gravity. Force of gravity is smaller because the mass of A is smaller, and we have a normal force going upwards. The normal force is smaller because it's canceling out a smaller gravity, but we know that those will cancel as well because the blocks are staying on the table. They're not moving horizontally. Now, if we have T2 acting to the right for block B, we should also have a T2 acting to the left on block A. These are acting as if they're equal and opposite forces. Technically, they're forces that are transmitted by the rope, but they act as if they're equal and opposite forces, and that's good enough for us. So they're equal in magnitude, opposite in direction. One is to the left, one is to the right. But block A also has another force applied to it. It has T1. And so what we can do, we know that the vertical forces will just cancel each other out if we're following a horizontal path. We won't worry about that. What we are going to look at is Newton's second law. And we're looking only in the x direction. For block B, the only force acting on block B is T2, and so that is the mass of B times the acceleration of B. For block A, we have T1 acting to the right, we have T2 acting to the left, so it's negative, and that is the mass of A times the acceleration of A. The last thing that we should have said specifically is that these two accelerations are the acceleration of B and the acceleration of A. However, A and B are tied together with a rope. That's one of the acceleration constraints we've talked about. And so whatever A moves, B will have to move with it. And so instead of distinguishing between those accelerations, we'll say that there's one acceleration A of the whole system. Now the question is, we want to find this ratio of T2 to T1. It's good to have those in an equation together. The only thing we don't know looking at our equations, we have the T's that we want to find. We have the masses of the blocks, which we know. The only thing we don't know is the acceleration. We don't know what the acceleration of the system is. And so that will be the variable that we'll try to eliminate. We'll try to eliminate that variable by solving for it in one equation and then substituting that into another equation. So here we have solved for the acceleration. Now we can plug that acceleration in. Instead of A, we're writing T2 over MB. So now we want to solve for our T2s because we want T2 to end up on top. And we'll continue to play with this algebraically. And find the common denominator. The reason why we did that is we want T2 over T1. So that means we're going to divide T1, and we get a factor of 1. And then we're also going to divide this term over. But if we divide this term over, instead of dividing by a fraction, we'll multiply by the reciprocal. And we see that it depends on the magnitude of both blocks, but in particular it depends on the magnitude of block B. And that makes sense that the heavier B is, the more of the tension, the more of the force that T1 has to be transmitted through T2 to accelerate B with the rest of the system. If B is, and if that's the case, this fraction is bigger and T2 is a bigger percentage of T1. If B is smaller, then it won't take very much force to accelerate it, and so T2 can be smaller, and we see that the fraction there will be smaller as well.